Is this
All right.
going to be a take-home test?
No. Okay, so find the horizontal tangent lines of that function. Okay. What could the graph of that function potentially look like?
Could be
Could be
crazy.
kind of a W, right?
3, 4.
And potentially, if you have kind of a W, how many horizontal tangent lines could there potentially be?
3.
4. 3. I'd say 3 at the bottom of the valleys and the top of the hill, kind of in between, right? Okay. Horizontal tangent lines would be where the instantaneous rate of change or the instantaneous slope is 0. So, using calculus, what do you think we're going to do?
Set y equals 0.
Find the derivative
Then set y.
and set that equal to 0. Yes, absolutely,
Yeah.
because you want to know when the instantaneous rate of change is 0. Okay? We want to know when the slope is 0. Well, how do we represent the slope? With the derivative, set that equal to 0 and solve. Alright? So y prime would equal, go ahead, anybody?
4x to the third.
Minus 36x.
Plus 0.
Okay? Now we want to know when the slope is equal to 0, so we just replace our derivative with the slope we want it to be. So 0 equals 4x to the third minus 36x.
Should this end up equaling the maximum and minimums?
This is where extrema would take place. Yes.
Questions?
Okay, press.
Is this going to test?
Yes.
You know, there's a-
Ow.
So would that be an acceptable way to double check it to see
This
if you
stuff,
did it right?
yesterday's
Okay.
stuff, that weird crap
Take
that they
out
always
4x.
use.
4x. X squared minus 9. Yep, 4x is your greatest common factor. You would
That's nice. Then we can do the plus minus 3.
difference of 2 squares.
Good job,
God, he is doing work.
Sorry, it was just the.
Divide everything by 0.
So 0.
0,
And negative
negative 3,
Yeah, like that.
3. So x equals 0, x equals negative 3, x equals 3. These would be the x values where the horizontal tangent lines occur. Okay? I didn't word the question great. How's the book going to word it? Determine the points, if any. Okay, so let's go ahead and we'll find our specific coordinates. Okay? These are the x values where the horizontal tangent lines occur. So if we need to find the coordinates
Plug it
where the horizontal tangent lines occur, what would we have to do?
plug back into the original.
Back into the original, right? Back into the original. Not into the derivative, because if you put them into the derivative, what are you going to get? 0, yeah. Okay, so you want to put 0 into the original. Looks like you would get 0, 7. So at the point 0, 7, there's a horizontal tangent line. Okay, negative 3. Now that's 81. 9. 162. Maybe.
Reassuring.
I'm guessing.
Negative 74.
Sure. You're the math teacher.
What? You have calculators.
It's not on my table, I don't. I was not
So do
provided
you.
with the calculator. And I got it.
Negative
I got it.
64.
Ooh.
Ooh.
I don't know.
He didn't use a calculator either.
But he's got the steel trap.
I got the steel trap. That's not right. 3.
Let's
Come on, somebody.
3 to the 4th.
Oh, that's 81.
Well, I got that. I know that's 81.
Alright.
So what are we
18
doing?
times
3?
9. Wait,
It was the 18 times 9, and 9 times 9 is 81, so 9 times
Perfect.
18 would be twice that. It's for
81 times 18
162.
times 9.
Bingo.
162.
Plus
81
7.
minus 162
Plus
would
7
be
is where I get
negative 81.
Plus
Yeah.
7. Which
Negative
negative 64.
That's the tricky part.
So is that what the calculators are doing when they do that,
No,
or
it's
do you
negative
not know?
74.
Negative 74.
Well, they just
I was
said.
going to go tally that bad boy up,
Ooh.
but erased it.
I just
So-
threw a guess out there.
Well, that's a point.
Mr. Alexander.
What, Luke?
Exact same thing.
Got the other one?
I'll write it back.
That's what I need right now, otherwise I don't care.
Shouldn't it be the same thing?
Boom.
It should be the same thing.
Except.
Positive.
No,
No,
what are you doing,
there's the
Kyle?
negatives.
Cap. Cap.
It'd be the same thing.
Yeah, it would.
No way. Come on, guys.
Yeah.
Alright, these are the coordinates where the horizontal tangent lines would occur. Now what?
For plugging it back in, would we be able to just simply find it using the extremis on the calculator, or will you actually want us to physically put it back in?
I don't, as long as the calculus work gave you the x values, I don't care how you get the y values. Heck, go to your table as far as I'm concerned,
That would probably be easier.
since you know your x values already.
Mm-hmm.
Okay? So any question on that?
But then I can do 2 birds, 1 stone, double check my answers as well.
Let's try another one.
Let's. So is there gonna be chain rule with this? Is there be chain rule with this?
Could be if the functions get hard enough, but, I mean, they wouldn't be worse than what you saw in that take home.
Is that X to the 4th?
1 over x to the 4th, yes. So what do we do?
Change it to x to the negative 4th.
Product rule.
And
Alright, derivative.
then negative 4x to the negative 5th.
Change forms.
Negative 4 over x to the 5th.
Okay. Set it equal to 0, because I want to know when the slope of the graph is equal to 0. So negative 4 over x to the 5th equals 0.
Isn't it never equal to
Never,
0?
because
Because you can never get the top equal to 0.
yeah, you can never get the top equal to 0. Yeah, you can multiply both sides by x to the 5th. That's not going to help you. There's going to be no solution to that. You'll have negative 4 equals 0. But also, negative 4 divided by something will never equal 0 because you have a negative 4 on the top. You never have a 0. So that basically means there are no horizontal tangent lines.
Can I put no solution or not put that?
No horizontal tangent lines. Okay, so that could occur. Alright, could definitely occur. Sines and cosines, there'd be an infinite number of places where horizontal
Yes.
tangent lines occur.
So
Okay.
would you just
Can
want
we
us
do one
to
of
do
those?
it from a range like how we did with the other? Because I forget when, but like
Could
we
you give
had
us
between
one?
0 and 10 at one point, and basically stated all of them for.
I would give you a restricted domain. Like I would say, give me all the horizontal tangent lines from 0 to 2 pi, or from negative 2 pi to positive 2 pi, or something like that. I would ask for all the tangent lines in a given interval.
Can
You
we-
have one of those on your practice. It's the same idea.
You should give us one though, we can do that.
Like maybe the
Please.
one from the practice.
Basically.
Yeah, that'd be fine too.
Nah, too easy.
Shut up, John. You
Just
don't
change
do
from
that.
sine to cosine.
Alright, I'll just.
Those are fight me, Carlton. Throw up the dukes.
Square root.
You think this is a joke?
I do.
Oh no!
Okay, Eric, let's go.
I'll beat it.
Stop.
It's terrible.
Guys. Y equals x plus cosine x, find the location of all of the horizontal tangent lines on the interval 0 to 2 pi. Okay. Y prime.
1 plus negative 1 minus sine x.
1 minus sine x. Set it equal to 0. Add sine x to both sides. What value of x in our domain would have, there's only one of them, what value of x in our domain would have a sine value of 1? Pi over 2.
So I take it you wanted in radians instead of degrees.
Absolutely. Alright. There, you can tell.
Oh,
Feed the ego.
What's that?
Feed the ego.
I added sine x to both sides.
Oh.
Instead of moving the 1 and then dividing by negatives, I just decided to move the negative sign by adding it to both sides. That makes sense? Okay.
Is that tricky?
So x equals pi over 2. That is the x value where the original function has a horizontal tangent line. So then if you want the original coordinate, you plug in pi over 2 into the original function, pi over 2 plus the cosine of pi over 2. Cosine of pi over 2 is
0.
0, so pi over 2 plus 0 is
Pi over 2.
pi over 2.
Yay!
Explain where the pi over 2 came from.
Yeah, so I needed to think what angle
Oh.
has a sine value equal to 1. So from 0 to 2 pi, so really that's just the first time around the unit circle. Where does my sine value equal 1? Sine is my y value. The only time the y value equals 1 is straight up at 90 degrees, aka
Okay.
pi over 2. Does that help?
Yeah.
Okay? So again, Amanda, there'd be a restricted domain, so you wouldn't have an infinite number of... Because otherwise, when you got here, if I didn't give you this,
We
you
could
could say pi over 2,
cover.
that'd be, what, 9 pi over 2, 17 pi over 2, and so on.
And as well as the negatives.
Okay, as well as the negatives, yes. Okay?
Forever and
So,
ever.
Let's see.
Alrighty.
A couple more on 123, no. 127.
73 and 75. 74 looks.
We'll do one like 73. One more here. Y equals 3x minus 4 over x squared. To do the derivative, we need to use quotient rule. Low
B,
d high minus high
B,
low
No, I can't.
all over the square of what's below. I just made this one up, so I don't know what I'm going to say.
Ooh, we can take the x's out.
3x squared, that'd be 6x squared, so minus 6x squared, minus 8, so plus 8x. Alright, and this would be 6x squared minus 8x right here. 6x squared minus 8x, but I'm subtracting that quantity, so it's minus 6x squared plus 8x.
quadrant. Factor that.
Oops. You can take out x's.
So you got like terms you can simplify on the top. You got an x that is divisible out of everything. To simplify, I'll combine my like terms first. So negative 3x squared plus 8x all over x to the fourth. Negative 3x plus 8 over x to the third. And everything is divisible by x, or you can factor an x out of the top and factor an x out of the bottom. That's what we got actually.
Yay.
Could you just take that out?
To visually see it, both of these I have a greatest common factor of x, so I'd be left with negative 3x plus 8 back there.
There's X on the bottom.
And essentially on the bottom you have that. And then so this one can cancel one of those. That makes sense then?
Yeah.
Okay. Now again, my goal was to find the coordinate where there were horizontal tangent lines. All we've done so far is what?
So a third of
We just
8.
found the derivative, so what do we need to do with the derivative?
No.
Set it equal to 0. So negative 3x plus 8 all over x to the third equals 0. How do you solve that? Multiply both sides by x to the third. Or really, just set your numerator equal to 0. Because the only way a fraction can equal 0 is if the numerator is equal to 0. As long as you make sure then the denominator is also not equal to 0, which it won't be in this case.
Because it can't cancel out.
Correct, yep. So negative 3x plus 8 is equal to 0. Subtract the 8, divide by negative 3, you get a positive 8/3.
Mm-hmm. Would you like us to change that to not be a, well,
No, I wouldn't change that at all. Anything else sounds ugly. 2 2/3 is nasty, and 2.6 repeating it is.
see, this is why we should be in base 12.
Okay,
Solve all our problems.
then find your coordinate. This won't be bad. What's 3 times 8/3? 8 minus 4 is 4, okay? And then, now this will take a little bit of work. That squared, well that's easy. 8 squared,
64.
3 squared,
No.
9.
so 4
So
divided by
times
64 ninths, or times 9 64ths.
I prefer times.
36 over 64.
You can simplify
Also
that.
known as 9 16ths.
Yay.
Alright,
Oh, that makes sense.
thanks Val.
Thanks, Dave.
8/3, comma, 9 16ths. Just a lot of, what's
Yeah.
that?
Yeah, so I didn't get 8/3. I don't know how you got 8/3.
8/3.
I just set my,
Here.
I multiplied both sides by x to the third, so that's still 0 over here. So then I have negative 3x plus 8 is equal to 0. Subtract the 8. So I'd have negative 3x equals negative 8.
Okay.
Then divide by negative 3 and I get my positive 8/3.
Got it. Got it.
Okay?
Oh, yeah, that.
Yeah.
Alright, so good?
Perfect. All good in the hood.
Alright. Real quick. So it's on the video.
Yeah,
Page 116.
Page 116. 59 to 63 odd. Page 127. 73 and 75. Okay? The quiz is not tomorrow, it's Thursday. Okay, the quiz is Thursday, the quiz is Thursday, the quiz is Thursday.
tomorrow.
Okay?
Quiz is tomorrow.
What? I was
Better not
so
be
not
playing any
expecting
jokes.
that.